I feel it in my fingers, I feel it in my toes. Here in Devon, it has been wet, wet, wet this year so far, and in many other parts of the UK. Not everywhere, though. Some places have been dry, dry, dry. How much longer will this ridiculously persistent weather pattern last? Are there any glimmers of hope for those places that have been so soggy? Welcome to this week's Met Office Deep Dive. Thank you for joining me this week. We do these every Tuesday on our YouTube channel. If you enjoy this sort of in-depth look at the weather, please do tell your friends about it. Send us a comment, hit the like button, subscribe, all that good stuff. It will only encourage us to do more of this sort of thing. Now, later in this week's deep dive, I'm going to be talking to two Met Office experts about a recent upgrade to the Met Office model. Really interesting chat that I did a few weeks ago. But before that, I want to take a look at some of the incredible stats that have been emerging in the last few days to do with the amount of rainfall across parts of the UK, the contrasts across the UK, and the sheer persistence of the weather patterns that we've been experiencing. Feast your eyes on this. This is the rainfall between the 1st of December to the 9th of February, compared with the average for winter as a whole. So we've not got through the whole of winter yet, but this compares what we've seen so far with what we'd normally expect for the whole season. Now, obviously, anywhere that's coloured in white or blue has already seen their winter average rainfall or above. Those areas where we've seen brown, well, we're still a little under the average. And you can see these incredible contrasts across the UK. The main areas to pick out, I won't come as a surprise to people who live in these areas, eastern parts of Northern Ireland, especially County Down, the south and southwest of England, parts of South Wales, into the Midlands, northeast England, eastern Scotland. All these areas have seen significantly higher than average winter rainfall, with still just under 3 weeks to go of the season. And in some places, for example, East Devon into Dorset, as well as County Down again, eastern Scotland, we've seen more than 1.5 times the average winter rainfall already. And just looking at a shorter time period, this is even more incredible, in fact. This shows the rainfall that we've seen in the UK in the first 9 days of February compared with February as a whole. So again, those areas coloured up white or blue have already seen their February average rainfall in just the first 9 days. Similar areas, south and central England, County Down, eastern Scotland, parts of northeast England have seen their February allowance already. Look at eastern Scotland in particular. 175%, in some places 200%, so twice their February rainfall in just the first 9 days, and with more to come during Tuesday and Wednesday. But another thing to pick out is this amazing contrast from eastern Scotland to the northwest of Scotland. The climatological signal has been flipped. What we normally average in a winter season has been flipped. Normally, it's northwest Scotland where we see the wettest weather. And so zooming in on Scotland, just to pick out some of the finer details, this shows the actual rainfall that we've recorded in various locations across Scotland, or a subsection of Scotland, for the first 9 days of February. And I want to draw your eyes to Aberdeenshire, where we've seen in Aberdeen 120 millimetres in the first 9 days. Boyne, 107 millimetres. But on the other side of the Cairngorms, 1.8 millimetres in the same period for Aviemore. So there's been this rain shadow effect where the rain has been piling up across higher parts of eastern Scotland, and then on the other side of the Grampians, on the other side of the Cairngorms, very little rainfall indeed. Kinloss and Lossiemouth, just over 1 millimetre. And then we've got Altbea, where we've got 1.4 millimetres in the first 9 days of February. Actually, most of that's been recorded in the last day or so, because if I choose a different time period, zooming in a little, then this looks at the period between the 18th of January and the 7th of February. That's a 21-day period, so 3 weeks up to and including last Saturday. And we've got a 0 there. Northwest Highlands, Altbea, where there's been no rainfall, 21 consecutive days without a single drop of rain in the northwest of Scotland, where we get a lot of rain at this time of year typically. Meanwhile, more than 300 and in some spots 400 millimetres in that same 21-day period in the east of Scotland. Amazing contrast because of this persistent weather pattern we've seen, where we've had southeasterly winds driving spells of rain in from the North Sea. And that's not just the only persistence record that we've seen. By the way, that's a record for Altbea with 21 consecutive dry days. Another record, Aberdeen Dice, 19 days without the sun. And that's up to and including yesterday, Monday. We look at the forecast, we could go 21 days without the sunshine in Aberdeen. 14 days without the sun in Lerwick. That's the longest since 1997. Consecutive wet days, meanwhile, across Scotland. Aboyne and Inverbervie, 24 days. Those records go back to the 80s, and those are both records for consecutive wet days, 24 in a row. And in other parts of the UK, we've seen an even longer run of wet days. So, for example, parts of the southwest and west of England, we've seen 41 days and counting since New Year's Eve of consecutive rainy days. Most notably North Wyke in Devon, Cardinham in Cornwall, and Asterbank in Worcester. So we've seen this long run of wet days in some places, and other places dry days, all because of a persistent weather pattern that we've been experiencing, in which weather systems have been moving in from the southwest and just getting stuck over the UK. Why has this happened? Well, these maps sum it up, and I covered some of this in the Weather Studio Live on Friday. We do the Weather Studio Live every Friday just after midday, but if you didn't catch it, I'll briefly summarise once again. And these maps were provided to me by Dan Holly, one of our expert meteorologists. And what they essentially show on the top here, we're looking at temperature. This is the average temperature for the 20th of January to the 3rd of February. So on the face of it, places where we normally expect cold weather, Canada, Scandinavia, Siberia, have been cold, warmer further south. Nothing too telling about that graphic. But when you compare those temperatures with what we'd normally expect, you can see some notable anomalies. So actually, the far north of Canada and Greenland have been warmer than average during that period, whilst it's the USA in particular that has been much colder than average. Remember those repeated cold blasts across parts of the USA during the last few weeks. Another cold spot, Scandinavia, parts of northeast Europe into western Russia, much colder than average here as well. So we've had cold air shifted south, and that has enhanced the temperature contrast between the USA and the Atlantic, which has resulted in a more powerful jet stream. This is the average position of the jet stream for this time of year. Comes out of the USA there, and then it fires across the Atlantic, pushing between Iceland and Scotland typically. But the jet stream that we've observed has been stronger than this. See the darker colours here, indicating a more powerful jet stream as a result of that enhanced temperature contrast. But as it's exited North America, it's not gone towards Iceland and Scotland. Instead, it's been shifted south. Why? Well, that's because of this warmer area over Greenland and northern Canada, which has resulted in what this shows here, higher than normal pressure over Greenland, which has helped to steer the jet stream as it's come out of the North American continent. It's steered it further south into Iberia. Lots of stormy weather, of course, in the last couple of weeks for Iberia. And with that jet stream being steered south, of course, the storm track has been steered south. So this is the average low pressure track you can see across northern parts of the Atlantic into Iceland, and then all those lows continue their journey to the north of Norway typically. That's the average, with higher pressure further south across Iberia. Instead, the storm track has been steered south of Iceland, into Ireland, into northwest France. These systems affecting Iberia, Central and Western Europe. And so we've had, because of these temperature contrasts across the North Atlantic and North America, Greenland, we've seen a more powerful jet stream that has also been steered south. So we've had some deep lows heading on a south shifted track. Not only that, But remember I said about the cold weather over Scandinavia? That's provided a block. So these systems have been arriving in from the southwest of the UK, and they've not been able to push further east. They've got stuck over the UK. In an average setup, which is what this is, lows get steered all the way along west to east, through Iceland to north of Norway, but you can see how they just get stuck over the UK. So that's why the south and southwest during recent weeks have seen repeated bouts of rain, and it also explains why the northeast of the UK has seen persistent spells of cloud and rain, because these systems move in from the southwest. I'm just going to play the next couple of days here to show what's going on. For example, this occluded front gets steered in from the southwest, brings a spell of wet weather, then it gets stuck over eastern Scotland. That fizzles away, next front comes along. Again, lashings of rain in the south and southwest, Northern Ireland as well. It then gets stuck again over eastern Scotland. These systems get bunched up and the isobars get squeezed, so that we see this persistent run of southeasterly winds and moisture being dumped across eastern Scotland and northeast England, because they can't go any further into Scandinavia, into eastern parts of Europe, whilst the south and southwest, Northern Ireland, gets particularly heavy periods of rain on and off. And that pattern, as you can see, is continuing through the rest of Tuesday and into Wednesday. What does that mean? It means, I can play this forward for a couple of days. You can see these heavy spells of rain. Rest of Tuesday pushing into the south and southwest. Northern Ireland seeing further wet weather. Then as these systems move north, they just get bunched up across eastern and central Scotland, northeast England. And we get this persistent spell of wet weather. Really just relentless through Tuesday into Wednesday and the very start of Thursday. So that weather pattern that we've been experiencing is continuing for Tuesday, Wednesday into the start of Thursday. That means it's going to be more rain for those areas that really could do without more rain, and we do have weather warnings for eastern Scotland Tuesday and Wednesday, which talk about 30 to 50 millimetres of rain for some of the wetter spots through the 24 hours of Tuesday, and 30 to 40 millimetres for some of the wetter spots through the 24 hours of Wednesday, with a component that will increasingly be of hill snow. By Wednesday, that's above 300 or 400 metres, 5 to 10 centimetres building up. And that's because there is a change on the way, and it really starts to take place later Wednesday. And I'm going to take the jet stream off there. I'm going to put on the temperatures. We've got this very cold area of Scandinavia, which occasionally has been felt by parts of Scotland, but at the moment it's relatively mild across the whole of the UK. However, later Wednesday, in fact through Wednesday and into Thursday more especially, these isobars begin to point to more of an easterly direction. So we're going to see more of that cold air push in across Scotland initially, and then during Thursday and into Friday, as a couple of lows depart, that cold air sinks further south across all parts of the UK. It takes a couple of days in the south, but eventually the colder air does move south. What does that mean? It means eventually we're going to stop talking about so much rain and start talking a bit more about hill snow, and it will predominantly be hill snow. And I'm going to show you that on here. If we go to Thursday mid-afternoon, first of all, there is a concern about additional rainfall through Thursday across parts of Northern Ireland because of this system. This is the point at which the winds begin to tilt more to an easterly direction rather than southeasterly. There's another low that may form along this band of rain that could intensify the rain across Northern Ireland and also prolong it. So that's something we're watching for Thursday for Northern Ireland, particularly, again, eastern parts of Northern Ireland. But elsewhere, what you can see is it's finally drier across eastern Scotland. Not much sunnier at first. It might be a little brighter, but at first we keep a lot of cloud. And then, after having seen some hill snow on Wednesday in eastern Scotland, we're going to see more and more of this band of rain turn to snow over the hills of northern England, and then eventually parts of Wales by the start of Friday, hills of Northern Ireland as well. So we're talking hill snow predominantly. At lower levels, it's still going to be outbreaks of rain. Could be some sleet mixed in later Friday as the whole system moves south, even at lower levels, as you can see, and even over some of the hills in the south. So Exmoor, Dartmoor, a few flakes of wet snow, but nothing too exciting. Let's take a look at why we're seeing the snow over the hills of the north. We've shown this before. This is the freezing level above sea level. So this is the height that you have to go to in the atmosphere for the temperature to go below freezing. And as a rule of thumb, roughly, where we see greys on the map, you'd normally think of snow towards sea level or at very low levels. Where you've got blues, you might think of snow over some of the hills. And where you've got the greens and oranges, it's more over the very tops of the mountains of the UK or even higher up than that. And you can see the start of Thursday, big contrasts across the UK. So we're into the greens across Wales and the south of England, but across Northern Ireland, Northern England, the east of England, into the blues. So at this stage, we're talking about hill snow. Northern and central Scotland, we're in the greys, although mostly it's dry here at this stage. In fact, if I take the colours off, you can see where the precipitation actually is. This is mid-afternoon Thursday. We've got this weather front that I mentioned across Northern Ireland, southwest Scotland into central areas. So rain for many southern and central parts of the UK, but you can see these flakes of hill snow emerging across northern England and southern Scotland. And playing that forward, more and more Thursday night, more and more of that snow starts to fall over the hills because these greys and blues are starting to sink further south. Again, way too mild further south, but even as we go through Friday night, you can see the colder colours start to push further south across many parts of the country as the system clears south. And it's through Friday that we've got this mixture of rain, sleet and hill snow through Wales, the Midlands and Northern England. Drier, finally, across Scotland, Northern Ireland, Northern England. Some sleet and snow showers coming into the north and east here, but Friday is really a damp day across central and then southern parts of the UK. Like I say, a few flakes of snow potentially for the higher parts of southwest England. How much snow are we talking about? Well, this shows where we are at by early Friday morning. Some significant snow over the mountains of Scotland, but patchy snow over the hills of the southern uplands, over the Pennines, Peak District, the Welsh Mountains, a few patches over the hills of Northern Ireland. So some hill snow over northern parts, but yeah, low levels, very little, if any, really. Very, very much a hill snow thing we're talking about for later this week and into the start of the weekend. And the weekend starts dry. A big change on the way. Here's how Saturday looks. An actual ridge of high pressure coming along. Blink and you miss it. It's a very brief window of finer weather, but finer weather it is, and it's going to be chilly with that. Here's how the temperatures by day are looking over the next few days. 11s and 12s in the south at first, but then we're into the mid-single figures by Thursday into the north, and then those mid-single figures come a bit further south by Friday. Saturday, 6 or 7 Celsius in the south, 4 to 6 further north, so a chill in the air, but actually Saturday is looking very, very pleasant indeed compared with recent weather. Some cloud in the east and some sleety showers coming into North Sea coast, perhaps some showers in the west initially as well, and cloud building into Northern Ireland. So we're talking basically about a 6-hour period in which the weather is drier and brighter before the next system arrives. And that system, once again, could well bring some hill snow. Here's Sunday. Actually, let's rewind that because the data didn't go far enough. This is now 3 a.m. on Sunday. So if you're up in the middle of the night across parts of Scotland, over modest hills generally, but perhaps at lower levels very briefly, a temporary period of snow. Mostly it's over hills, northern England likewise, before it then gets replaced by rain coming in from the west and milder air. So yes, the potential for a bit of snow across northern hills, across the Welsh mountains and further north as this next system moves in from the west and bumps into the cold air. But by dawn, most of that's turned back to rain, any snow at low levels tending to disappear very quickly if it happens at all. But never mind the cold weather and the potential for hill snow, what may excite you the most is a change in the weather on the way for later this week and into the weekend. Now, I mentioned that 6-hour period of drier weather on Saturday, but that may not be the only 6-hour period of drier weather to come, because by the time we get to Sunday, here's the front coming in from the west. What you'll notice immediately is low pressure is no longer sitting to the southwest of the UK. Instead, it's coming in on a more climatological track. It's coming in on a more north-shifted jet stream. Westerlies rather than south to southeasterly winds. The block to the east of the UK finally shifting a little to allow these systems to move through. Now, I don't want to be too clever about the weather from Sunday, because from Sunday onwards, essentially, it's Atlantic-driven weather. We've got more low-pressure systems on the way, and in the various computer models, the timings of these and the shape and the track of them are all over the place. Suffice to say that Sunday onwards, it's going to be unsettled. There'll be some frequent lows coming in from the west, in all sorts of different configurations. There'll be more wet and windy weather, but the important takeaway message is that they're going to be moving through on a bit more of a north-shifted jet stream, and they will be moving through a bit more. So I'm not promising a prolonged dry period. Far from that. It is going to be unsettled next week. But what I can say, as a glimmer of hope for those areas that have had 41 consecutive days of rain, is that in this kind of setup that we're going into next week, at least we'll have 1 or 2 dry days in between systems. The rain won't be so relentless for those areas that have been so wet. It will be more like a typical unsettled winter weather pattern than the amazingly stubborn winter weather pattern that we've had since the start of the new year. And really, at the moment, well, I'd take that. Now, speaking of modest improvements to the weather and to weather modelling, I spoke 4 weeks ago to 2 experts here at the Met Office about a recent scientific upgrade to our Met Office model. To talk about the recent scientific model upgrade, I'm joined now by 2 of the Met Office's finest minds, Beth Woodham, Scientific Manager, and Dan Surrey, Chief Operational Meteorologist. And you 2 have been involved in lots of stages of the development of this model, haven't you? Can you explain a little bit about what you've been involved with?
Yeah, absolutely, and hi there everyone. What we've been doing is, as part of my role, I lead operations to research, where I have a team of operational meteorologists who work with me to do model evaluations of our current models and trial and experimental models as well. And what we've been doing is working closely with Beth's team to evaluate the new scientific model upgrade from its very early stages, where we were testing various different aspects of the model, to where we've got to now, where we've got something live and really, really good and suitable for our needs. So we've been working together. We've been exploring how forecasters look at the models, how they see it, what they're getting out of the models, where they think it's good, where they think it's bad, and then working with Beth's team to refine some of the science involved in that, understand some of the objective verification statistics that we've got, and then define and establish model characteristics so that operational meteorologists know where the models are going to be really, really good, you can trust them, where they may not be quite so good, and then to think about what they can do in their forecast to try and account for that.
So scientists like Beth don't just tweak a few dials and boom, we've got a new model. This is a collaborative effort, isn't it, between operational meteorologists like you, scientists like Beth, and you're just working constantly in collaboration.
Exactly, because we're sharing perspectives. So what my team are bringing to Beth's team are the perspective of the operational meteorologist and other downstream users, explaining that where we're using the models, why we're using them in that way, and then what we're gaining from Beth's side is understanding the underpinning science, and understanding where the models are going to be good and bad from that. So yeah, it's absolutely a collaborative effort. We couldn't do it without each other. You need that operational perspective, but you also need that science perspective to be able to make a good model upgrade.
Yeah. I mentioned a recent scientific model upgrade at the start there, but actually internally we've been calling it OS47 or PS47, and those acronyms might creep into our conversation today. So let's define what they mean. What does PS47 and OS47 mean?
Yes, so OS47 refers to our operational suite, that's the OS. That's the collection of models that we're running now live. It's our latest version, and that's the data that will go to our opmets like Dan and his team to produce the forecast. It will also flow into things like the app and the website and to other customers. The parallel suite, which is what we were running this model as up until a few days ago, is
it's run in tandem, isn't it? It's kind of to give meteorologists like Dan that opportunity to test things.
Yeah,
they've got two models that they can compare like for like.
Absolutely, and we also want to test all the technical aspects of it. So for a few months up to our go live of having the new operational suite, we run this parallel suite, and yeah, just check we're happy with everything until we go live.
Now, with the new supercomputer, we've obviously got more power that we're able to use. And that's enabled us to make some scientific changes and improvements, hasn't it?
Yes. So we have quite a few changes in this new model. Firstly, we're now running our global ensemble out to 10 days, whereas previously it was only 7. We've made lots of upgrades to the physics. So this means things like how we represent convection, how we represent rainfall and cloud, and by changing these we can also improve other aspects like temperature, for example. Another thing that we've been able to do in this new model upgrade is improve the observations that we're putting in when we set the model running. So
yeah, and this shows the additional observations that we've been able to bring in, doesn't it?
Yeah, so we've got a new type of observation, which is global aircraft observations. So lots of civil aircrafts actually carry sensors for temperature and winds, and these are then relayed down to receiving stations on the ground. This is just an example of where observations come from just a random 6-hour period. There's actually over 9 million observations being shown on this plot. So This is lots more observations that we can add at the start of the model run to make sure we're representing the atmosphere in the best way that we can. So this has really improved our forecast skill. It's a really big step for OS47.
Some of these parts of the globe are places where we don't have much data.
Absolutely, yeah. You can see we've got a lot of coverage in Africa, Southeast Asia, parts of South America, and yeah, traditional observations, there's not that many in those regions. So this is really good for improving forecasts, not just in those regions, across the whole globe.
Yeah, we're never going to have perfect coverage of the atmosphere around the globe, are we? And that's one of the issues when it comes to producing forecasts, is you need to know what's happening elsewhere on the planet, don't you?
That's right. You need as good observational coverage as you possibly can. The advancements we've seen in satellite imagery over the last few years have been fantastic. Meteosat 3rd generation came online in the last couple of years, which has improved our observational coverage and given us better satellite imagery over a pretty large chunk of the world, actually. But yeah, improving the observational coverage that goes into the data assimilation from model is really important. It's a great leap forward. And when you look at this map, you can see some areas, you think of a lot of the weather that we get over the UK does come from the west, so seeing improved observational coverage over parts of Canada, for example, is going to be beneficial. And of course, we have teams of operational meteorologists all over the world working for the Met Office, so seeing some of the areas where we've got improved observational coverage is going to have a knock-on effect on helping them in their roles in different parts of the world as well. So yeah, it's a great advance.
Absolutely. Really, and the improved physics, the improved observations, they've ultimately, as you found, Dan, with your testing, led to improvements in some of the aspects of the output. So this shows a rainfall comparison between the previous model, current model, and the radar. Talk us through this.
Yes, this is great and a really great example of some of the things that we've seen. This is a pretty typical example of what operational meteorologists have noticed and seen, and we're really, really pleased with this. The new physics that we've introduced to the model upgrade have meant that you can see a much better representation of the frontal rain. If you look at the radar on the left-hand side there, you can see a pretty broad band of precipitation across the UK, a lot of blue colours on the leading edge of the rain over the eastern part of the UK, down into southwestern Netherlands and Belgium, and that's lighter rain. The brighter colours, the yellows, the reds, the ambers, they're the heavier rain. And then if you compare that with what you see in the middle and then what you see on the other side of the map, you can see that the rain band is much more coherent, much broader across the UK, much more realistic in PS47 compared to OS46, where there's a narrower area of rain. And you can also see some gaps. If you look over the Midlands, for example, and also over parts of northwestern England, you can see some gaps in the broader area of rain that don't exist in reality. So basically what I'm saying is, in the model upgrade, larger areas of rainfall, larger rainfall structures are much more coherent and therefore much more realistic, and that's really, really good news for our operational meteorologists. The other thing that's much more realistic is the representation of light rain and drizzle, which is underdone in our previous operational model, and in our new model upgrade, that's much better captured as well. And that's great news on so many levels. It's great news for our operational meteorologists who are obviously making forecasts for it, downstream using it. Downstream users, so for example, hydrometeorologists, flood forecasters, hydrologists who are using that information, they're getting much more realistic input for their rainfall runoff models and river flow models. And then also for users of our app, for example, if you look at the rainfall maps in our app, they're much better able to capture rainfall at the moment and provide a much more realistic depiction of how precipitation is moving. And this example is actually just of a frontal zone, a pretty typical frontal zone over the UK. We're not seeing quite so many smaller scale showery structures on these particular images, but even the smaller scale showery structures that we get affecting the UK, they look a lot better in the new model upgrade than our previous model. So that's really, really good news, and something that operational meteorologists really, really appreciate, and something actually that we can really easily show to viewers and the general public as an example of where the model is clearly an improvement.
Yeah, absolutely. And another thing that this has come from feedback from the previous model, isn't it, about the cloud representation and this known bias in certain situations with cloud. And that's been improved as well, hasn't it?
Yeah, that's right. Biases around the bases of low cloud and around one or two other things such as visibility, lightning and temperature have improved, which is really, really good news. A lot of our opnets are involved in aviation forecasting, and as you can imagine, with aviation forecasting, you're very concerned about potential aviation hazards, so cloud bases over airfields and airports are really important, as in visibility. So yeah, model improvements in terms of biases with low cloud bases is a really, really great advance and a really, really great step forward. And we've also made some improvements to our gust diagnostics. So getting gusts right is actually quite difficult. There's quite a lot to it. It's quite complicated. You've got to factor in topography. You've got to also factor in the fact that with gust, you've got a downward component of that contributes to the gust and a horizontal component of the gust. You've got to bring the two together, and that's really quite a complicated piece of science, quite a difficult thing to get right. But actually, it's really, really pleasing to see that in the new model upgrade, this has improved and has got a lot better. This is an example from Storm Gretti in January, and what you can see is the whites and the blacks and the greys, they represent higher gusts, and then lighter gusts are the blues and the greens and the yellows. And the thing to focus on actually is the swirl of this sort of C-shaped curl of high winds over the western part of the English Channel across into the Scilly Isles and southwestern Wales. And you can see a smaller area of greys, blacks and whites in that area, and that's actually a bit more realistic. The circles you can see, by the way, are observations and give you a bit of a sense of model verification. And basically the headline message to take away from this is that both models showed pretty extensive area of high winds coming into the southwestern part of the UK, but the magnitude of those winds were much better captured in the new model upgrade, which is again really, really good news, and that all feeds into our app and our web services. So that's an example of us providing much more accurate forecasts for users, operational meteorologists, general public, everyone alike.
It's subtle, isn't it? The subtle changes on top of what was already a really good model, really good forecasting of wind gusts, but these incremental improvements year on year add up over time.
That's right, exactly. Sorry.
I was just going to say it's probably worth saying that these plots here are showing data straight from the model, but actually at the Met Office we have another layer called post-processing, where, for example, bias corrections are added, which make the products that customers receive, for example, what goes into the app, even more accurate than what you see here.
Right, yeah, really important point.
Exactly, yeah. The post-processing teams at the Met Office do some absolutely fantastic work in taking the raw model and making it even better. And yeah, what you say about the versions of the model, statistically our models have long been among the best in the world. So yeah, you're right. We're taking something that's already really good and making it that bit better.
Yeah.
So it's great. Yeah.
Can show how much better it is in some aspects of the forecast on this graph. This is the improvement in UK winter temperature forecasts, which is really important for the energy industry, isn't it?
Yeah, and things like gritting and de-icing. We can see red shows the average error for OS 46. That was our previous operational model. We can see it's below the 0 line, which means we've got a cold bias. PS 47 in blue is much closer to this line, so we've reduced the bias by something like 0.2 of a degree on average.
And that's just an average, isn't it? Yeah. These small changes really do matter when it comes to things like gritting and things that are based on key thresholds. And not only have we got the better representation of all these different parameters, we've got real-world improvements in tropical cyclones as well, and other aspects of tropical weather.
That's right. The improvements we've made, we've talked a lot about and focused a lot on our high-resolution UK models while we've been talking, but actually our global model as well has seen some significant improvements. We've done some great science and put some great science in there. And one of the things that we've been able to do is improve tropical cyclones. Modelling of tropical cyclones is a massive challenge to any modelling agency. But what we have done is we've been able to make improvements to the track of tropical cyclones. We're a bit better at that than we were. And also the intensity of tropical cyclones in our new model upgrade is a little bit better than the last couple of model versions as well. And global model improvements impact other things. We're getting other areas of convective rainfall around the world. We're able to capture that a lot better. So, for example, over the tropics and subtropics, rainfall systems there are better handled. Some of the gusts are something else that have improved in the global model as well. And we're seeing some of the temperature biases improving as well. So a lot of our forecasters are very much UK focused in what they're doing, but we do have teams of people looking at all sorts of weather systems around the world and working around the world, and they're able to benefit from that improved science as well when it comes to making their forecasts.
And speaking of the global model, Beth earlier mentioned the improvement to the global model ensemble, MOGREPS, and how that's going out to 10 days. The ensemble, of course, being the multiple simulations of a model so that we can account for chaos theory and so on. What does that extension mean for Chief Operational Meteorologist like you, Dan?
Well, it's a really great thing that we've been able to do there. To extend the ensembles out further in time does give us extra data and another tool to use when it comes to thinking about how the forecast is going to evolve in the slightly longer term. That benefits national severe weather warnings, and as was, it benefits that in that we've got a little bit more information then to go on when it comes to issuing these warnings, but also when it comes to looking at things like you featured on the deeper dives before, when you're looking ahead into week 2, if you like, we've got a bit more information there to go on to help us give a better steer as to how conditions can evolve in general terms in sort of 5 to 10 days time. So yeah, it's really important for that, and a great step forward for us to have that capability to go alongside other capabilities that we use. Yeah,
because this is just one tool in the toolkit that you use operationally. You're using European model, global, the American model. You're using all of those on a daily basis.
Exactly. I mean, the way you could look at it is that our modelling suite is the suite of models that our operational meteorologists know the best. I mean, we've been using them for so long that we know them very well. It's kind of like a bit of a best friend, really. I know our models pretty intimately, I suppose, in that respect. And yeah, alongside that, we know where our models are good, we know where they're not so good, and so to help complement that and help us build up a better picture, we are drawing on other model output, particularly that from ECMWF. And yeah, a lot of the forecasts that you see reflect that blend of model outputs, because yeah, we can't get everything right in our models. We get a lot of it right, but we do draw on other information as well to try and capture the full extent of uncertainty and to add additional detail to our forecasts. So ECMWF, I don't know if we've talked about this before, but that's it's a collaborative, a European collaboration of a number of different national European Met services who've come together, pooled some resources to build a model that's very much focused on some slightly longer term forecasting. So yeah, we draw that in alongside, and so our models, and having it go out to 10 days is great for us. It gives us another tool, as you say, to help improve our warnings, help improve our medium range forecasting.
Yeah, absolutely. And it's worth saying that when you see forecasts on the television from the Met Office or on our YouTube channel, the data has already been slightly modified to match what the chief meteorologist like Dan has suggested. So, expecting the rain to move in a bit quicker, etc. Our meteorologists upstairs, they make those changes to our graphics as well. So we're using all the information at our fingertips and trying to portray the most realistic and best results to viewers. Lots of excitement internally about all these improvements. Even more excitement, I imagine, about what's next. What does the future hold?
Yeah, absolutely. Of course, we're already planning far out into the future, thinking about how we can take advantage of the new supercomputer. One way we can do that is increasing the resolution of our models. So things are calculated over smaller areas. We can give more detail in the forecast. We'll also continue to improve how we put observations in and the observations that we put into our models. Always continuing to improve the physics, the ways we represent the things like rain and cloud. And also, of course, at the moment, machine learning is a big topic of interest, and we're really thinking, we know machine learning models are really good at some things, physical models are really good at some things. How can we actually find that optimal blend rather than relying on one or the other? How can we blend these together? So these are the things that teams all across the Met Office are working on at the moment to continue improving forecasts.
Yeah, I can't wait to see those improvements and those changes, and we'll have to bring you both back on next year, maybe.
If you'll have us.
Yeah.
Yes, please. And yeah, really interesting to talk to you. Thank you so much for your time.
Thank you.
Thank you.
Really interesting to chat to Dan and Beth there about improvements in our weather modelling. And if you enjoy that sort of thing, if you enjoy these deep dives, I know this week's been a long one, but some people love that. And if you are one of those people who like these in-depth forecasts, don't forget to subscribe, send us a comment, send us a question. We might answer it in a future deep dive or on Friday's Weather Studio Live. But for now, that's all from me. Thank you for joining me this week. Bye-bye for now.